The Regional Center for Seismology for South America, CERESIS, presents Earthquake Reinforcement of Existing Adobe Housing in the Andean Region. In ancient times, different cultures built large and impressive earth constructions. Throughout the Andean region, we find rather well-preserved sections of palaces and temples. A recent United Nations report estimates that between 1/4 and 1/5 of the world's population lives in housing built with earth, be it adobe, mud brick, or mud wall. Throughout the Andean countries, Argentina, Chile, Bolivia, Peru, Ecuador, Colombia, and Venezuela, more than 35 million people live in adobe houses. In the case of Peru, the National Institute of Statistics and Information reports that approximately 1,900,000 adobe houses exist out of a total nationwide of 4,400,000, 2 out of 5. 35% of the population, 9 million Peruvians, live in these adobe houses. Throughout the Andean region, construction with adobe is still normal practice. It is understandable and quite logical that adobe construction be continued. It is a tradition that dates back to prehistorical ages. The building material is at hand, it costs little or nothing, the adobe brick is sun-baked, and it is as easy to use as a building block. Adobe houses protect dwellers from extreme temperatures. Adobe walls support the weight of heavy rain-proof roofs. Nevertheless, adobe itself is not first-class building material. It is highly vulnerable to earthquake shaking, floods, and erosion caused by rain and winds. It is not resilient and it accumulates damage suffered from previous earthquakes. The majority of those who live in adobe houses are people with the lowest incomes, which precludes any plan that calls for rebuilding their homes with better materials at their personal expense. Approximately 4,600 million years ago, our planet Earth was a nebulous mass, a very, very small part of the universe. For us present on the Earth for only the past 100,000 years, in human perspective, our planet is as it is and as it will be. However, we are well aware of a process of continuous change inherent to the slow evolution of our planet, when we observe the natural phenomenon that originate in the Earth's interior and its atmosphere. Earthquakes and volcanic eruptions are expressions of the complex processes within the Earth's interior. The seismicity, that is, the frequency and distribution of the earthquakes that occur, is not uniform worldwide. There are enormous extensions of territories where the probability that an earthquake will occur is practically zero. On the other hand, many other regions are noted for the severe and frequent earthquakes that occur. One such area is the Andean region, which contributes 15 to 20% of the total seismic energy liberated by our planet. During the past century, at least 450 earthquakes of magnitude 6.5 or higher have occurred throughout the Andean region. A magnitude 6.5 earthquake is equivalent in energy to 6 million tons of dynamite, an amount of energy equal to 1,000 atomic bombs of the type that destroyed Hiroshima during the Second World War. Fortunately, earthquakes do not liberate their energy on the surface of the Earth, but at great depths. Otherwise, earthquake-prone areas would be totally devastated and uninhabited. Every year on the average, we can expect that 4 or 5 of these large earthquakes will occur somewhere in the Andean region. Earthquakes of magnitude 8 or more, with an explosive potential equivalent to 136,000 Hiroshima-type atomic bombs, occur in the Andean region on the average of 1 every 8 to 10 years. These huge earthquakes are truly catastrophic. The frequency and magnitude of the earthquakes observed during the past 4.5 centuries in the Andean region leave no doubts as to the destructive nature of this implacable enemy, which humans must learn to live with forever. What preventive measures can be taken by the millions of Andean inhabitants exposed to destructive earthquakes? A practical measure of prevention for these people is to reinforce existing adobe housing in earthquake-prone areas, applying technology developed by the Regional Center for Seismology for South America, CERESIS. It is certainly not the only solution. However, this technology is the result of research during 4 years and tests with the Large Shaking Table at the Structures Laboratory of the Catholic University of Peru, under the responsibility of experts in adobe construction.
Hemos efectuado una serie de estudios en el Laboratorio de Estructuras de la Pontificia Universidad Católica. Se han ensayado una serie de módulos en una mesa vibradora sometiéndolas a terremotos tan fuertes como aquel que ocurrió en el año de 1970.
In short, we are presenting a technology for earthquake reinforcement of adobe housing, developed by CERESIS, produced by experts of the Catholic University of Peru, and funded by the German Cooperation for Development Program, GTZ. Its application and diffusion was carried out by CERESIS. Reinforcement of pilot houses. The technology that CERESIS offers has been designed to save the life of the inhabitants when a strong earthquake severely shakes their adobe houses. The idea is to provide the house with additional structural strength to retard its possible collapse, many more seconds than it would take for it to collapse without any reinforcement. The reinforcement technology developed retards collapse of the house for enough time to allow people inside to escape outdoors unharmed before the house actually collapses.